This video is going to show how Pomeroy solves the system of equations and then also the proving that happens at the same time. So the first thing I'm going to do is I'm going to take and set up my equation, and apologize, my allergies are getting really bad at the school. I set up those first, and then I take and shake out the x and y. So I would put the constants of, the coefficients of 5, 1, -7, and -4. And then what I do from here is I find my determinant. The determinant is found by the first diagonal of 5 times -4, which is a and d, minus my b, which is 1, times my c. With that, I get -13. And then what I do is I'm going to set up my inverse. So the inverse of my matrix that I set up is 1 over -13. And I'm going to leave this blank. And then I'm going to write my original matrix of 5, 1, -7, -4. I'm going to put my variables of x and y equals, and I'm going to write down my 1 over my determinant of -13. Apologize again. I know it picks it up really loud. My inverse, and then 7, -2. And in order to find my inverse, I'm going to take my a and d and switch their spots. So 5 is going to go down here, -4 is going to go up here, and then my 1 is going to become negative, and my -7 is going to become positive because I'm going to switch their signs. And then I'm going to copy that right over here. Now, what I'm going to do is my first step of my proof step for the question down below is I'm going to multiply the left side. So I'm going to show my work. I have -4 times something plus -1 times something. I'm going to do that twice. Oops. Okay. And then I have row 2, and I'm going to write down the same thing again. But I'm going to use 7 and 5. So 7 and then 5. And that's column 1 and then column 2. And what I'm going to do here real quick is I'm going to move these over just a little bit, so I have a little bit more room. Oh my goodness. And then row 1 and row 2 are done, and then I'm going to put in column 1. So I have 5, -7, column 1. And then I have 1, -4. And then what I'm going to do is I'm going to set up my other matrix over here. I'm not going to take the time to color code, but I have row 1, which is -4 times something, plus -1 times something, and 7 times something, plus 5 times something. Now with this, if I do it this way, and I don't want to show all the work on the left side, then I wouldn't. So we get 7, -2. And then what I'm going to do is I'm going to bring down my fraction of 1 over -13. And then in my calculator, I would plug those values in. I'm going to bring my x and y down. I'm going to bring the fraction of -1 over 13 again. And then I'm going to write down those numbers there. So in my calculator, plugging those in, I'm going to get -13. 0, 0, -13. It's awesome. That main diagonal matches what is my denominator or my determinant. And then over here I have -28 plus 2, which is a -26, and 49 minus 10, which is a 39. Take my values and divide that all out, and I get my proving statement of the identity matrix 1, 0, 0, 1. And then I get xy equals, and when I plug that part into my calculator and do the math, I'm going to get 2 and -3. And then I would write down my point of 2 comma negative 3. And I get there. Now, that would get me to a correct answer on this question. And then what I'm going to do is I'm going to build from here. So at this point, I'm going to jump to the prove section. And with the proving, I'm going to take my A matrix. I'm going to write it down. So my A matrix from my original question. And then I'm going to write down my inverse. So I have -4, -1, 7, and 5. And then in my original matrix, I had 5, 1, -7, -4. So what I would do now is down here on the proof, I will write down that I took A -1, the A inverse, times A, and that I showed that it equaled the identity matrix of this. This work here, okay, that comes from this line here. So I'm not going to show that whole multiplied out. This work here, I already multiplied it. This work here, and this simplified. Okay, that shows this proof. So since I've already gone through and done all that math, what I'm going to do is write down below it, I'm going to say work shown above in number 4. With that, you don't have to highlight it, but if that's what you need to do so you can see it, that's that proof. Now, I've already done that work, so I'm not going to do it again. So what I need to do is I need to take my order and switch it. I'm going to take my matrices and then switch the order, so my A inverse and my A, and I'm going to prove that that also equals the identity matrix, which is how you prove that two matrices are inverses of each other. So with that, for the sake of writing, please bear with me here. I'm going to copy that. I'm going to paste that. Whoops. That didn't do what I wanted it to do. Still not doing what I wanted it to do. Copy. Paste. There we go. And then I'm going to write these in the correct order. And what I'm going to do is, this is going to be A. This is part of my inverse, but what I'm going to do is I'm going to move that fraction to the backside. And the time it took me to do all that, I could have just rewrote it, but I was trying to be fancy. So what I'm going to do just now is I'm going to multiply my matrices like I did before. Okay? 5 times something plus 1 times something, which is row 1, -7 times something plus -4 times something. And I'll rewrite that again. This will not be the same multiplication as you just did above because the order is going to be different. Your rows and your columns did switch, but you should still get the same answer. Okay. And with that, I'm going to plug in, that's my rows, so I'd have -4. Probably should not do it that way. -4, 7, -4, 7, which is column 1, -1, 5. And if you're unsure, this is row 1, and this is row 2, which is where row 1 and row 2 came from. They weren't pink to begin with. I do apologize. And so with that product, I now have -20, 13. So I have -13, 0, 0, -13. but I still have that fraction of 1 over negative 13 on the outside. And then what I just have to show with that is that this comes out to be 1, 0, 0, 1. And that's all the work that you have to do. So yes, it's a lot. But if you want to, you can rewrite the work down, or you can watch the other video proof. I do apologize, there's a bell in it. But that's what you get to do.